A number of members of the MDC would like to watch this, and they were going to watch the recording.
That sounds great. We were just thinking that might be a good idea.
And staff as well. So right now, the archaeology crew is doing final cleanings so we can do a drone shot of the site.
And you can see us well, or me well, I guess.
I can see you and the screen.
Yeah, so what we're going to do is we've got slides that will probably take 30 to 40 minutes. And each student has about 2 or 3 slides at different points that they'll rotate through to explain.
That's great. Looking forward to this, Dan.
Oh, well, thank you. It's been a neat project to be involved in. It's been a great opportunity. Yeah, my students are following along on their laptops, but we're all in the room together.
Awesome.
It's the middle of finals exam week, Matt.
You got to be busy.
Everybody's busy, and then everybody gets to go home and relax, which would be good.
Yeah. And Dan, I've got your core right here.
Oh, yeah.
It's in perfect shape.
That's awesome. Thank you.
Yeah. So I gotta either mail this to you or next time you're here, give it to you.
Yeah, one or the other. If I end up thinking I'm going to do some field work, I'll let you know. But so far, I'm not doing a lot of coring between now and the summer.
Okay. It's I've got it on my desk to remind me.
All right. Thank you. I'm glad you found it. That's helpful. Like I said, I've never left a boar out in the woods, and now I've done it twice at the site. But it's good to get all this work in, even though it was quick. So you can let me know when we'll start, and I'll just, give a quick little intro, and then I'll hand it off to the students, and we'll be good to go from there.
Yeah, I think we're ready to go, Dan. I'm recording, so you should be all set.
Awesome. All right. Well, with that, then, yeah, thank you, Matt, and thank you to the members of the Montpelier Descendants Committee for the opportunity to be involved in this research. We are hoping that what we share with you all this afternoon provides additional perspective on the burial ground site through tree ring analysis. And we have about a dozen students this afternoon who are going to share not only our results, but also the background context, the methods, the results, and then the interpretation of those results that we hope to give you a full picture of what we're finding using tree ring analysis at this site. So each of these dozen students will rotate through with different slides. Feel free to ask questions during this presentation, and we'll certainly be able to take questions towards the end. You can see all the names of the students at the bottom of the slide. This really has been a group effort. They've worked hard over the course of the semester to do some tree ring analysis that just, at times wasn't easy, but we have been able to complete some good analysis. So with that, I will turn to the first slide, which is our introduction, and I will pass it off to Nicole.
All right, so hi everyone, my name is Nicole, and today I'm going to be talking about why we were looking at trees for this study and what the data from the trees can tell us. So as I'm sure you're aware, there's not a lot of archaeological data at the site. There's not, unlike the Madison Family Cemetery, unfortunately, there's no tombstones with the names and the dates that the deceased died. So we don't have a lot to go off of there. Matt and his team have uncovered a lot of artifacts on the site that help to give us clues as to the general time period that we're looking at for this site, but unfortunately they don't give us a lot of specifics into the exact dates that we're looking at. So that's why we turn to the trees. Obviously the area is very heavily forested, and so we use a process called dendrochronology, dendro meaning trees, chronology meaning time, to look at the trees and get an age estimate based on that. So what we do is we take a core sample of the tree, to look at the rings that the tree has, the growth rings over time. And from that, we can look at the relative width of the rings and compare them to known climate records in the area over time and compare them. So if we know that the climate record shows that there was a lot of rain in this particular year, then we can expect to see a larger ring because the tree had enough resources to grow in that amount. And so by doing this, we can attribute certain calendar year dates to different ring widths. And once we've established that and given each ring width a certain calendar year date, then we can do what's called cross-dating and compare a bunch of different samples to each other and try to match up the relative ring widths between those. And once we compare all those, we can also get what's called a reference chronology, which is basically taking the average of all the ring widths and putting them on one timeline that we can use to compare future samples to, so that we don't have to go back and compare them all to the original climate data that we collected. And so by doing this, we can determine what calendar year the tree's first initial growth ring was at, and therefore when the tree started growing in this area, and when it was an open field, and when it started becoming a forest, and therefore when it could have been used as a burial ground. And so that's some kind of background on dendrochronology and the process that we use for this study. And now I'm going to pass it on to Rachel to talk about some of the backgrounds of Montpelier in general.
Understanding the history of the way the land was used at Montpelier can really help us to understand the history of the burial ground itself. In 1720 was when it was deeded to Ambrose Madison, and when 4 enslaved people and an overseer took up residence on that property and started working right away, clearing forest and getting things started to develop a plantation. So the whatever infrastructure was involved with that as far as buildings and fields. Between 1730 and 1844, 4 generations of the small Madison family were occupied that site, and over 300 enslaved people lived there. Originally, it started out just with tobacco being the primary crop. And this necessitated large areas of land for the crop, and also for caring for it with the drying and processing of the tobacco. Later on, there was a diversification of crops. And so that meant other fields were going to be used, and then major land use projects were undertaken by the enslaved population under the direction of both James Madison Sr. and Jr., who would become the president. During this time, there was, in addition, like I mentioned, to other crops, there was also a very large blacksmithing facility that was built that serviced the whole area, as well as some other projects, parks, fields, additional housing. It's unknown which locations of the Montpelier Burial Ground were used during which times of the Madison's residence. We do know in 1844 that Dolly Madison divided and sold both the physical property and the enslaved individuals. However, many continued to live on the property under 5 subsequent owners during just that short time period between 1844 and when legal slavery ended in 1865. So there was a lot of change. It's assumed that the burial ground or portions thereof may have continued to be used by the enslaved that were living there during those times. In 1865, there was that whole period, and the period post-Civil War was very unstable. We do know that there was multiple owners, although the records that each kept was sparse. So, and we know that some people that had been there under slavery conditions will continue to live there afterward. We also would like to know if the burial ground continued to be used during those times or was lost. But all these changes in the land use really obscures the record of what was used when who was there at what time. There's a lot of regrowth of trees and then clearing and then regrowth again. So this also might have disturbed the tree record as well. There was a stability occurred to the land. Well, stability and ownership occurred in 1900 when the DuPont family took over the property. This is a map from 1908 that they commissioned. The star is the location of the Montpelier Burial Ground, and the yellow block is the house. But they also undertook some very large, major earth moving and changing of the landscape. And these things also affected an understanding of where the Montpelier Burial Ground was and where those burial sites were. We do know that there were at least 300 people enslaved by the Madison family. And we know that in 1984, 38 of those grave sites were known. So it continues to be of deep interest as to the locations of the other burial sites and understanding where and when those were used. The DuPonts, although they had stability and ownership, their modifications continued to change what the area around and make it difficult to determine. This included, this map from 1937 lets us know how much the land had changed. The star again is Montpelier Burial Ground, and that forested area we can see is most likely, well, you can see how close it is to the racetrack and other developments at the edges. So that is the background for the land as we try to understand what happened there.
Thank you, Rachel. As Rachel said, the land of Montpelier is the history of the burial ground is complicated due to people using the land, maintaining it, and not using it, which would lead to the rise of early successional species like the Dendrochronology, the tulip poplar, Juniperus virginiana, the eastern red cedar, and Fraxinus americana. And out of those species, the Juniperus and the Fraxinus are indicators of post-agricultural use. And if we compare I believe the two maps Rachel had, the 1908 DuPont survey and the 1937 aerial photograph, the area of the burial became rapidly forested. And I'd like to pass on to Steve.
All right, so the Montpelier Descendants Committee goal was to demonstrate how the lives of the enslaved people made possible and inform the ideas of universal liberty enshrined in the Declaration of Independence and the Constitution, and then also denied those things to them. That's from their website. So just a little background on the committee. It was established in June 2019. They provided people with a better understanding of the American slave trade. They showed physical and interactive experiences. So they had buildings, artifacts, different experiences for people to see. They use artifacts to teach visitors about human history by showing them these actual physical things. They also had exhibits, two of which, one was a color through a child's eyes, slavery from a child's point of view. And then they also had the mere distinction of color, which is mingling history of slavery from the past with mindsets of today for Montpelier's role in the slave trade. And then their human agency and support efforts. So we did dendrochronology of the Montpelier Burial Ground that was found that we mentioned earlier. We're doing research to determine the age and spatial extent of that burial ground, and then ongoing research is going to provide more knowledge to Montpelier about its history. And then how does it help our location we're going to help them find information to support them in finding a location for a commemorative monument they want. And then more historical context for the land and burial ground is also going to be useful information to Montpelier as a whole. And then next is Allison with your hypothesis.
So with all of this information we have just presented and all of our previous knowledge, we can infer that this area was once not forested. It was an open land. And using the LiDAR and GPR data that was previously done on this area, we can now look at our hypotheses for this, for this project. So first, we can hypothesize that our dendrochronology results of the trees in this area can allow us to piece together the forest succession timeline, which can then allow inferences into when these burials occurred. And then as a secondary hypothesis, we could also look at any difference in like across the ages of the trees within the different burial grounds throughout this area to see if the years of use of the burial grounds is additionally different as well. So now we're going to move on to our method section and pass it on to Holly.
So to start, we sampled a variety of trees located both within and around the proposed burial ground. We focused mostly on oak trees, ash trees, tulip poplars, and eastern red cedars. For each sample, we reported the tree's GPS coordinates, that being latitude and longitude, its species, and what we called its status, which in our case was whether it was living or dead or broken, whether the tree was upright or fallen, whether we were sampling one of multiple stems, etc. And there were two methods of sampling, that being tree cores and discs. For living trees, they were cored, and as you can see on the right, a tree core doesn't really take a lot of the tree out. It's only a little sliver, so it doesn't damage the tree. Whereas dead trees, they had discs taken out of them, and we'd like to give a special shout out to Bruce Hoover, who did the chainsaw work to get the discs from the trees. And discs do give more information than the cores by minimizing the chance of hitting like a spot on the tree that's maybe different than the rest. Whether that'll have like a locally missing or a false ring. So just being able to see the entire ring record helps us to minimize these risks. And then when we were in Montpelier in October, we focused on doing tree cores. And as you can see on the left, Felipe is demonstrating how to use an increment borer. In this method, we insert the borer perpendicular to the trunk and we push it and turn it into a tree until it reaches the center of the tree, and then the core is removed. Then, once it's removed, it's placed into a paper tube and labeled with its tag number, species, and the date of samples in order to keep track of all of our samples. And now I will pass it on to Gabby to talk about the next step.
Okay, so after we took the cores and brought them back to the lab, they were removed from their paper tubes and glued onto wooden mounts with the transverse side up, which is the transverse side basically is like a top-down view of the surface of the tree, and that's where you can see the rings. Then they were sanded with various grit sandpaper, and then finally sanded with micro finishing film until you can clearly see the cell boundaries under the microscope, just to make sure that we're accurately measuring the rings like as best as we can. And the tree ring series were then frosted by comparing the patterns of wide and narrow rings on the core, and matching them up to other samples to see the years when the tree started growing and when it died, and compare that to the trees in the area. And this is very objective, subjective, sorry. And then, so its statistical correlation test was used to objectively verify the cross-dating and make sure that we were all seeing the same patterns and that they all are matching to each other. After cross-dating, the cores were marked to denote every decade to make sure that we knew the year, like the specific years of each ring. And then they were scanned at 1600 dots per inch to then be uploaded into the computer to be used into various programs that Felipe is going to talk about next.
So we first collected the samples, then we paired the samples, and now we had to collect data from them and then analyze that data. So at first, we typically use the program R, or the programming language R, which has multiple programs, the first one being mtree. We took the scans, we put them into the program, and we created a path going through every single ring. Once we had that path, we zoomed in and we put dots at the beginning of every single ring, for then the program can measure the distance between each one. So we then collected that data, exported it as CSV files, combined them, converted them. That is not very important. What is important is we then put it into a program called DPLR. So DPLR took the data that we collected from all the samples and put it through a bunch of statistical the correlations and comparisons of all the measured trim widths. These take the tree growth into account and put it into graphs and tables. These graphs include like spaghetti plots, correlation tables, and correlation by series and segment plots, which we will be talking about in the results part of this presentation. So with this, we can easily cross-date, which is more objective instead of the subjective cross-dating that we talked about before. And we can detrend them, which basically means when trees are dying, the widths get smaller. So we can make sure we correlate everything properly, even with different growth rates. And these can be caused by disturbances like trees dying, droughts, and other such things. Now I will be passing off to Bailey with the results.
Okay, so the results that you're seeing here today are based on 12 total samples that we've analyzed, 11 ash trees and 1 poplar. We've also sampled some cedar trees that have not yet been cross-dated. Those will take a little bit more time. And all of the samples that we've analyzed today, they were sampled during our trip to Virginia, October 14th and 15th of this year. So this is a correlation by series and segment plot. It shows the correlation between tree ring widths. The blue color that you're seeing, the darker blue, indicates a stronger correlation, which indicates that our data is more accurate and that the ring widths are more similar and that the tree cores have actually experienced similar climate factors over the years. We don't see any red, which is a good thing because red would indicate that there's insignificant correlation. So this is good. And the green here just shows that the ends of the cores could not be correlated, which is. And next, I will pass it off to Alexis. Okay, so here we're looking at a table of correlations between our sample cores. As we can see, all of the correlations are positive and also around the 5 mark. This means that they are very significantly correlated. This is important to us because this shows that the trees experienced similar climate events, so the ring widths are similar in length, and therefore they're closer in age. So then we moved on to plot them into spaghetti plots, which Christine will talk about.
So this is spaghetti plot. So on the y-axis here, we have the ring widths, and then on the x-axis, the years of growth for the trees. There's also 2 trees here. The orange one is an example of a tree that grew in open conditions. It didn't really have much competition. It wasn't shaded, just had very good access to the sun and like nutrients. And then the blue one here is one that grew in like shady conditions, so it had more competition. And this plot just kind of shows the different growth patterns of them. Also to mention ring widths, so the rings, if they're bigger, it's like better growth for the tree that year, and if they're smaller, it's more struggled growth. This is also created in Excel, and Allison's going to explain more about this spaghetti plots to you.
Thank you. All right, so this is another spaghetti plot of all of our samples. So we have all of our 12 trees on here, which most of them show the open growth pattern where we see, yeah, okay, yeah. Sorry, I got turned around there for a second. So most of them show this open growth pattern, with a few exceptions. We have the majority of our samples beginning to grow within the early 20th century. Which we know is when the DuPonts took over the land, which it was in 1901. So that could have had something to do with it. And then After our plowing ceased in this area, we do see our early successional species, like cohorts of red cedar begin to grow, and we also have our ash trees, which most of them are shown here. So that's kind of our beginning plot here, and then I'll be passing it off to the GIS people. So we're seeing this.
All right, so this map shows the ash and tulip poplar tree locations in the Montpelier Burial Ground. You can see the burial ground pathway in that teal color. The tree that is marked 1919 is the only tulip poplar tree that we measured, and the house location is off to the right of this map. The base map is, of course, a satellite image, and all of the other trees that are marked in the orange are the ash trees. And only 2 of those trees were alive. That was trees 404 and 414, which would be 2 1907 years on this map. And this could be due to ash borer presence in the area. So now I'm going to hand it off to Nicole with another map.
Okay, so this map is once again showing the aerial image collected in 1937 that Rachel was showing before. And this is just showing us what the area looked like during that time period and where the trees that we sampled were relative to what the forest looked like at that time. And then this is a LiDAR map in the background, which is, it measures topography, so different elevations in the surface of the area that we were looking at here. And so we have a few different areas highlighted for you here. The berms are what are elevated regions, and that's where a bunch of dirt was pushed up. As a farmer plowed a field, they push all the dirt up to the side, and this forms what we call berms. And so from the location of these, you can see one around the teardrop formation around the upper part of the map, and then 2 along the bottom portion of the map. And what these indicate is that the area within them was plowed at one time because all the dirt is being pushed up to the side. And so this can give us a little more context into the fact that the central part of the burial ground, because it was likely plowed at the time because of the formations that we're seeing, that the trees there are likely going to be younger because they had to wait until the plowing stopped until they could begin to grow. And so that matches up with the data that we're seeing here. The later trees that we have are in that central area. And so that was just another feature that we were looking at here in order to verify the dates of our trees. And then you can also see some of the road beds that we highlighted here for you just for context to orient yourself with the map. And then the pathways are highlighted in the pinkish color.
And here we can see that 1908 map that was commissioned by the DuPonts. We can see it overlaying the LiDAR data, where we do know where some of the burial sites are. We can see from that a couple of our trees, a couple of our oldest trees were very close to that, very close. Oops. It's going for the arrow and didn't get it. But that circular group of trees on the upper left of the screen, that was present, that group of trees was present in 1908, and we see that 3 of our oldest samples actually were from that location. The two oldest were in that location. So, and one of those trees manifested a slower growth pattern, indicating that that area did have, was forested much earlier than the others. And this empty fields that we're seeing on the 1908 map had most of the trees that we sampled currently. So that gives us an idea, confirming again that in early 1900s, most of that region was still open, with the trees coming later.
Now, this map, it shows all the trees we sampled, including the ones we weren't able to cross-date in time. And it shows them by diameter, by height, which means we take the same, at the same height, we take the diameter of every single tree. And by that, we can see how much growth there is per tree in each area as compared to all the trees that we sampled. We then move on to this map, which is in a LiDAR, like on top of a LiDAR, shows every single tree by species type. As you can see, the orange ones are typically the ash, which are the ones that most of the ones that we cross-dated. And there are a lot of other trees that we haven't yet, so we can get a lot more data later on once we discover this. So I'll now give this to Bailey for the discussion.
Okay, so for our discussion, we're gonna go back to our original hypotheses. So we did know that at one point, this probably had to be an open field, at the time that they were used as a burial ground. And forests probably had to come after. So since we have cross-dated our trees, we know that early forest succession probably happened in the early 1900s. And we see this from our cross-dating data and visually on the maps. And this makes sense because the DuPonts took over in 1901, and historically we know that land ownership tends to lead to land use change. So for the boundary of the burial ground, we're not exactly sure where the boundary is. So there would need to be more sampling and more data done in combination with the LiDAR and GPR data that has already been done. And here you're seeing a 1908 map that was commissioned by the DuPonts, and you can see here that these are cedar thickets, and so these are kind of drawn a little bit dense in 1908, which means that early succession was probably happening a little bit before this. Cedars are early successional, and they're looking a little bit dense on the map, and especially for them to use that term cedar thicket. So that's a good indication of the early 1900s as well. So I'm going to pass this over to Krista.
Alright, so we're going to talk a little bit more about dendrochronology and specifically other literatures. So as Christina said earlier, the focus of this project is to use the dendrochronological data to find where the forest line begins and uncover the entirety of the burial site. And while there is other literature that demonstrates how dendrochronology can be used to date land use, there's few studies that focus specifically at burial sites, as we did. And in comparison to these other studies, there's more confidence in the dendrochronological data because we are cross-dating these, which lets the data be more accurate rather than just counting the rings. And this site has been presumed to be previously a non-forested area, so these successional trees coming in shows that, you know, if we can accurately date them, then we can get more information on that. So this dendrochronology is just another important piece of the puzzle in uncovering that. So in one study, this was done in Johnson County, Arkansas, done by Garrett Kloof in 2018 and a few other researchers. So they used dendrochronology and lichenometry to date the land use at the grounds in this burial site. So they took 12 tree cores that were sampled at DBH, and these were red oaks, white oak, and red cedars, eastern red cedars. However, they only counted the rings. They did not cross-date these, but the relative ages were the youngest being 71 to the oldest being 118, I believe. However, because of this, they were able to, once they were dated this, the lichens that were on the tombstones, since they knew that the burial ground came before the trees, they were able to use the lichens to sort of date when the tombstones were placed by measuring the lichens and then determining a growth rate, which by doing that, they found that the earliest gravestone was relatively in the 1800s and the most recent being in 1922. And then another study, this was done in Poland, so you know, the geography will be a bit different. However, there were abandoned cemeteries that became incorporated into the landscape. So the researchers, Obla and Major, used dendrochronology to find the origins of the cemetery, which they collected a total of 15 cores taken at DBH. However, same thing again, they only counted the rings of this and they found that the earliest trees dated back to the 1960s. So what's different in these other studies is that we are cross-dating these trees to get further accurate data rather than just simply dating the trees where they could be a few years younger or older. So yeah, we just cross-dated them to make it very exact, and I'm going to hand this all to Caitlin.
So tree ring widths can be affected by climate stressors. So an abnormally wide ring would indicate warmer climate and more water availability, while an abnormally narrow ring would indicate cooler and drier climate with less water availability. Tree ring widths in this study were used to cross-date the cores and discs that we collected from Montpelier in October of this year. And we only cross-dated the ash trees and found that the years with unusually wide rings were 1931, 1945, and 1975, while the years with unusually narrow rings were 1936, 1956, and 1978. This could be the narrow rings could be due to the emerald ash borer, which is an invasive beetle species that was first discovered in the United States in 2002. And since then, they have caused over 95% of ash tree mortality. Of the 11 ash trees that we sampled at Montpelier, only 2 of them were still alive. Ash tree mortality caused by emerald ash borers takes place between 4 to 6 years. First, the larvae feed on the vascular cambium tissue under the bark, which inhibits the tree's ability to transport water and nutrients, and less water and nutrient availability during those final growth years leads to narrow tree ring widths. So now I'm going to pass it off to Alexis.
Okay, so dendrochronology is important because it can be used to reconstruct changes in climate within a specific region or globally if the range of core samples is broad. Reflecting on our GIS mapping and our ring width correlation, we see our sampled trees are within a close range to each other and they have strongly correlated ring widths. Okay. Sorry about that. Therefore, it can be assumed that the trees are similar in age and began growing around the same time after the land was previously plowed. So our research is done with the intent of helping the Montpelier Descendants Committee with recovering as much information as possible about the burial site. Because 11 out of the 12 trees date back to the early 1900s, it can be assumed that the land use in this area that required it to exist as an artificial field predates the 20th century. The dates of these trees give a further context on how the enslaved community at Montpelier impacted the land and the time period that it was in use. To recap, we found that the 2 oldest trees were co-located with the Burman cusp, which were likely an area that was not plowed as much. Our analyzed tree cores show evidence of forest succession around the time of the DuPont's transfer and ownership. It is possible that this area was open ground throughout the 19th century, including after the Civil War. We were able to analyze 12 trees total, 11 ash and 1 poplar, but the cedars will likely take more time for analysis. Further research could look into collecting more samples, preferably older trees. This could help with further understanding how the area has been used throughout time.
We would like to give our acknowledgement to the GEMS program at Rider University for their endowment and sponsoring the trip to Montpelier, Dr. Brooke Hunter, and Dr. Evelyn McDowell for providing background information about the history of slavery in New Jersey and the land that they sit on. And we would like to thank Matt Reeves, Bruce Hoover, the Montpelier Field School staff, and students, Wendy, Sophia, and Arthur, for helping us support trees, providing information about James Robinson Jr., the property, and how the burial ground is.
Thank you all. So that is our presentation. We are happy to take any questions that you all might have for us.
Yeah, thanks, Dan. That was a really interesting set of presentations. I see we get three folks from the MDC here, Rebecca Davis, who's the oral historian at Montpelier, and then also we have the chair of the memorialization committee, Henry Anglin, who's also a descendant, and then Allison James, who's the project manager for the MDC. And I don't know if any of them have questions. I had some questions, but I'll wait for Henry and Becca and Allison.
I'm good. Go ahead.
Okay.
So let me ask a question. The ash trees were the most significant, evidently, and looking at the age of the trees, is that because of the growth period for those trees? And were there other trees there that weren't sampled that were larger trees or that could provide additional information? That's one of the questions, two of the questions I've had, actually.
Yeah, those are great questions. And I think what I'll do is I'll offer, if there's any student who wants to take a try at answering these questions, you're welcome to. If not, then I'll answer them. But does anybody want to answer either of those two questions? All right, Felipe. Yeah, and then I can chime in as well.
So if I go back to one of my slides with the ArcGIS maps, you see how there's a diameter by height. That means there are larger trees with much more growth. It is possible that they are not older, they could just have grown more, but it is also possible that they are older and not necessarily we didn't sample them, because as you can see, they are different colors. The oranges are the ones that we sampled, plus the purple in the top left. Other than that, we couldn't sample any of the others because it's much more difficult and we need more time to do so. So I don't know if that answers your question, but
let me even add on to what Felipe is saying. I really like how you pointed out this slide, Felipe. There are these large, I'm doing the same thing. There are these large trees over here. So this is the size, the diameter of those trees that we did not sample because they're some of them appear to be hollow. These are very large tulip poplars that are associated with that erosional gully, or at least the large gully by the road there. And that could be something that we could reconsider. You know, maybe even if they're hollow, we might be able to get some older rings out of those trees. And as you mentioned, the ash were really valuable to us. One, because they're already dead, right? So we could get a full cross section out of them. They're also valuable because since they're dead, that record is going to disappear as those logs decompose on the forest floor. And then thirdly, they're valuable for the reasons that James mentioned, that ash trees in other studies have been shown to be often associated with post-agricultural succession, first trees that come in after a field is abandoned. So they are a useful indicator with their age that this might be that first cohort of trees that came back after this land was no longer open ground. Does that help answer that question, or those two questions?
That does help a lot. Thank you.
And actually, I do have a question now. Thank you so much for this presentation. It was absolutely amazing. I guess in my mind, I was kind of using the wooded area of the burial ground as an artificial boundary. But based on what the information that you guys just presented, the burial ground could actually expand much further beyond the wooded area based on the dates that you guys are showing, correct?
I think that's certainly possible. And I would defer a little bit to Matt,
Okay.
but I think that's certainly possible.
Thank you.
Yeah, you're right, Becca. The GPR data, we have preliminary data back from the GPR survey in October, and it is much larger than the wooded area, the copse of woods that's shown in the 1908 map right here. It's more to the north and northeast. But one question I've got, I'm glad you have this, and like Becca and Henry said, this has been a really enlightening conversation. Really appreciate all the work y'all have done. The dates that are on this map are those the sprout dates for these trees, or the earliest cross-dated dates?
Who wants to try answering that question? Anyone? Yeah, Nicole, why not?
So the dates that we have on here are the earliest dates that we got from the cross-dating procedures, and so they're the earliest partial ring dates. So not like the full of their first full year ring of growth, but the earliest partial one that we could begin to record. So these are the ones that we got from the cross-dating, basically.
Yeah, and do you want to add into that, Rachel? That's a good point.
These were cross-dated for accuracy with each other, but the year that you see is the first year or second year, like it's in that very beginning of when the tree sprouted.
And maybe the one thing that I'll add on to their points is that if you go back to this nice slide that Colleen had about methods, you can see actually both of these. We were quarrying at a height of about, a yard, 3 or 4 feet above the ground. So if we get back to that innermost ring, which is maybe a partial ring, that's the age of the tree at sort of chest height. And so we're missing some rings, right? So maybe you could add in a fudge factor and say, oh, well, really that seedling might have started 5-10 years before that. That's possible. It's hard to know exactly what that would be. But I also think that this is still instructive because it helps you to visualize that this area probably was starting to look more like a forest by these years, whereas seedling that might be just hidden in grass, you might still think of that as a land use of an open area at that time. Again, we're largely quarrying at this height just because it's really hard to pour down at ground level to get that shoulder strength. But the ash trees also, the ones that Bruce cut with the chainsaw were probably within a foot or two of the ground. So, and those, the advantage of those again is that you can't help but hit center when you have a full cross section. So we do have the earliest ring on those.
And the question I've got related to that, in the 1908 map, unfortunately, there's two 1908 maps. There's one 1908 map that is close to the main house, and that's the one that shows the cedar thicket close to the house, but it doesn't include the area of the burial ground. And then for the property map, it's hard to tell whether the cedar thicket extends into the burial ground, but given the presence of cedars, we're assuming it does. And I have two questions. One is there any way to date the cedars that are there? And then two, if this area was a cedar thicket in 1908, and you had any of these trees, either the ash trees or the tulip poplars coming up through them, how much would suppression of the growth put the sprout date that you can see with the cross dating, on or off? Because I noticed, like in Northwoods at Montpelier, there are oak trees, there are saplings, and when you cut them, they've been suppressed for decades. There's over dozens and dozens of tree rings on those, but if you did a coring of it, you probably wouldn't see any of that. So the question is there any way to date the cedars? And then if this was a cedar, is there any way to determine if it was a cedar thicket? And then what would you all assume in terms of the age of that cedar thicket, given the age of the trees as they emerge through the cedar thicket? Or is this too much to ask?
No, it's not too much. These are good questions to ask. Maybe I'll try answering these first unless anybody wants to chime in. So the cedars are largely shown here in this nice map that the GIS students did. So you can see they're sort of concentrated down towards the bottom center, just to give you that spatial location. The other thing that I think is interesting that you're referring to, what if these trees were just growing slowly for a long period of time? As Allison pointed out, most of these were growing pretty rapidly. And, there's really only one tree that starts off growing slowly. That's this dark gray line. And that tree, MBG 23A, was our designation for that tree, but that's the tree, I believe that's right over here. So it's right adjacent to that copse. So that sort of fits with this notion that these trees are all growing rapidly initially. This tree is the oldest. This tree is growing slowly, maybe because it's shaded by neighboring trees at that point in time, where the other trees are not. Is it possible that, you know, we're missing decades worth of growth between the 3 feet that we sampled in the ground? Yeah, but then again, keep in mind that most of these were sampled only a foot or two off the ground. And also that there's anecdotal evidence in the literature just that, you know, eastern red cedars don't grow underneath a shaded canopy. They need to have open grown conditions, and we're seeing a lot of, you know, cedars sort of interspersed throughout this part. So I think we're getting the first cohort of trees after the after, you know, this land was no longer kept open.
And Dan, do you think, is there any, for the cedars that you have, is there any way to get a date on those?
Yeah, so at first I was very confident. I thought we're gonna all plow through this and we're gonna get dates on the cedars. And then I became a little less confident. And then I worked on them some more on my own, and then I became even less confident. But I'm gonna perhaps try some over the break. The problem is that eastern red cedars, particularly in this early successional context, are prone to having false rings, which means maybe an extra ring boundary for one, you know, calendar year, or a missing ring. And in fact, you can follow these rings around this, you know, the diameter of a tree, and you can see at one point it's one ring, another point it's two rings, or maybe at another point it completely disappears. So it's even hard to get two different radii on the same cross section to necessarily agree and to know which radii is correct. So we could just do ring counts, but again, you know, ring counts wouldn't tell you is this post DuPont or is this pre DuPont. I mean, you could be off by a decade or two.
That's helpful to know. It's too bad those cedars are so tricky.
Yeah, they are a little bit tricky. We'll see, but so far they've been tricky.
That answered all my questions. This is great.
Great. Well, we have also been working on a report that we're doing a few final edits on that we will share with you all. We're happy to share these slides. Of course, you have the recorded presentation. And yeah, I think maybe just on behalf of the class, thanks again for the opportunity to both visit Montpelier and learn about the history, not only of the site, but, you know, how it's relevant to our country's history overall, and then the opportunity to contribute to this meaningful work. So thank you for that.
And thanks for all the work you all did. It was great to see that you get some good cross dating of trees. That was exciting.
Yeah, I think we're off to a good start, and maybe we can add to this more later.
Yeah, thanks for all your help there. That's a lot of information that we can look at, and it helps us a lot. Thank you.
You're welcome, and yeah, again, I think this has been a great opportunity for all of us. So thank you, Henry. All right, well, yeah, thank you, Matt, as well. And if there's no other questions at this time, we'll send those documents to you in the next day or two, and I'm sure I'll be in touch.
All right. Thanks so much, you all.
Thank you.
Good luck for the rest of the semester. Bye.
Bye.